Hi guys, welcome back to Com Concepts Pro. I hope you very well understood the concept of hashing that I explained you in my last video. Today I will tell you what is collision in hashing, and we will also discuss two of the collision resolution methods, which are separate chaining and coalesced chaining. Collision is the situation where two keys resolve to the same hash key, which means when two data keys are allotted the same index position in the hash table by the hash function. This situation of collision can be resolved by some collision resolution techniques. In this video, we will learn two of the conflict resolution methods of chaining, which are separate chaining and coalesced chaining, and rest of the methods we will be learning in the next video. Let's see the chaining technique first. Chaining again consists of separate chaining and coalesced chaining. In separate chaining method, the hash table slots are connected to a linked list and keys are stored in the nodes of this linked list. Whenever there is a collision, the next key is stored into the next node of the linked list. The hash table slots in this method store the pointers to the linked list connected to them rather than storing the actual values. Let's understand this with the help of an example. So these are the key values that we have to store in the hash table, and let m is equal to 7. That means there are 7 slots or buckets available in the hash table. We would be using division hash function to generate the hash code. So the first key 50 mod 7 will generate the hash code 1. So 50 will be stored at the index position 1 in the hash table. Next key is 700 mod 7 will generate hash code 0. So 700 will go to index position 0 in the hash table. Next key is 76 mod 7 will generate the hash code 6. So 76 will be stored at the 6th index position in the hash table. Next comes 85. So 85 mod 7 will again give us the hash code 1. But as we can see, there is already a value available at the index position 1, which is 50. So now 85 will be stored as stored in the node of a linked list attached to this slot of the hash table. Next is 92, which again conflicts to index value 1. So this is actually collision. The collision is happening at index value 1. So where then this value 92 will be stored now. So 92 will be again stored in one more node of the linked list attached to this slot of the hash table. Next key is 73. 73 mod 7 will give us 3. So 73 will be stored at the index position 3. Next is 101, which will again generate the hash code 3. So 101 will also be stored stored in the node of a linked list attached to this slot of the hash table. Next we will see coalesced chaining. In this conflict resolution technique, whenever there is a collision, the colliding key will be inserted to an index position which is empty before the last occupied index position in the hash table. And this newly discovered index position for the colliding key will be stored in a separate column next to the original index position where the collision actually occurred. In this technique, all the keys are stored in the main array itself. So this is an open addressing technique. Let's see an example for this as well. So these are the keys that we have to insert in our hash table. And let's say our m is 10. That means there are 10 slots available in the hash table. So one by one we'll see where to insert the keys in the hash table. First key is 10, so 10 mod 10 is 0. So 10 will be stored at the index position 0 in this hash table. Next key is 15. 15 mod 10 gives 5. So 15 will be stored at the index position 5. Next key is 26, which gives the hash code 6. So 26 will be stored at the index value 6. Next key is 30. So now there is a conflict because 30 mod 10 again generates the hash code 0. So now in Coalesced chaining we have to find out the empty slot available from the last index position. So 30 will be stored here at the index position 9. And the index position 9 for this key will be stored here. Because ideally according to the division method 30 should be stored at the index position 0, but because of the conflict we had to store 30 at the index position 9. So index position 9 will be stored here in the next column. So whenever we have to search for the key value 30, we'll come to the index position 0 and we'll see that the actual value stored here is 10. So we'll look in the next column and find out the index position where our key 30 is stored. Next is 25. Again there is a conflict because again 25 mod 10 generates the hash code 5, but 5 is already index position 5 is already occupied by the key value 15. So 25 will be stored here in the index position 8, which is the next available empty index position from last. Now this index position 8 we have to store here because whenever again we will search for the key value 25, we'll go to the index value 5, but the actual key is 15. So we'll look in the next column and we'll come to index position 8 to see that 25 is actually stored here. Next is 35. So again there is conflict. So 35 will be first of all saved here. In the empty position available from last. Now this 7, the index position 7, where it should be stored. See, for 35, first of all, where we will go to the index position 5. But the key value is 15, so we'll see in the next column. In the next column, index position stored is 8. So we'll go to the index position 8. Here also the slot is not empty. There is one key value already stored here, but the next column is empty. So we will store the index position 7 here. So now when we'll look in the next column of this index position, the index value is stored is 7, and then we'll go to the index position 7 and we'll find out that our key 35 is stored here at the index position 7. One more example of same kind. Our key is 45. 45 mod 10 again gives 5. So first of all we'll store 45 here from the last available index position. The empty slot available is index position 4. But now where to store this index position 4? So first of all we'll look for the key 45 at the index position 5. The slot has some other value. So in the next column there is index position 8 stored. We'll come to index position 8. There is some other value stored. In the next column there is index value 7. So we'll go to index value 7, which has got some other key value stored. But now here the next column is empty. So we can store the index position 4 here. And when we'll come to the next column of this index position, we'll find that index position stored here is 4. Then we'll go to the index position 4 and we'll see that our key 45 is stored here. So in this way coalesced chaining works.